Okay. So I'm sharing my screen. Please
Yes, ma'am.
acknowledge me whether it is visible or not. Are you able to see my screen?
I think it's getting loaded. It's not yet.
Okay. I'll again share it. I hope it is visible now.
Ah, perfect, ma'am. Yeah, and your camera is also on right now.
Yeah. Mhm. Um, just wait a minute. All right. So, good morning, ladies and gentlemen. So today we are here to learn, gain, and share knowledge on various applications of statistics. Um, on the various applications, and basically we are going to see how statistics is related with the data science. So before starting with my session, I would like to thank the IT and the Pradesh University for inviting me in this 5 days international faculty development program. And I also would like to quote my special thanks and congratulations to Professor Divya and her team for successful commencement of the FDP. I wish all the participants to have fruitful learning from this FDP, and hopefully I would do a justice to this particular session. So let's begin with this session. I hope I am clearly audible to everyone and my screen is clearly visible to each and every one of you.
Yes, ma'am.
So
The mic is muted.
sure. I don't know what's happening. I'm really sorry. Uh, okay, so today in this session of statistics for data science, we will investigate statistics as a technology on its own and also how it is used in data sciences. So we will be looking further more about data science in the later slides. So for now, we will be considering that data science is actually a science behind the data. And it includes everything that I expect you have heard about. So like data analytics, machine learning, artificial intelligence, and other similar areas. So to begin with, let's have a look to the definition of the statistics first of all. And before my explanation for statistics, I would first like to know it from my dear participants that what do you have understanding about the statistics? What exactly you mean by the statistics? Then I'll come to the definition of the statistics. So let's begin with a kind of discussion over this particular topic, and let's start with what you have understanding about the statistics. So anyone can respond or reply. So according to you, what exactly is a statistics? All right. So I'll go further. So statistics is the art of never having to say you are wrong. So you might be thinking that this is not the exact definition of the statistics, but I am going to tell you the limit and the scope of the statistics through this particular definition. And obviously, this particular definition also defines what exactly is a statistic. So basically, why I am saying that statistics is the art of never having to say you are wrong. Why I am saying this? Because statistics has its own limitation, right? So, for an instance, let me try this. Okay. So for instance, you have a data like data A, data B, right? And I would define data A with the data A and data B with the set of 1, 2, 2, 4, 3, 6, 4, 8. Right? So this is my data, right? So can you identify the relation between the data A and data B with these values, that the values that I have specified over here? Oh my God. Just wait a minute. There is some problem with my system. I think slides are lost. I'm again sharing my screen.
Ma'am, if you wish, you may turn off your video now because I think that may cause an unnecessary delay. And the slides are also off.
Yes, there is some
Yes,
problem
ma'am.
with my system. Yeah,
Yeah,
I'll
yeah.
be
Okay.
turning off my camera. Yeah.
Yes, ma'am. Now the slides are okay.
Okay. Okay. Thank you so much.
Yes, ma'am.
So basically, what I was saying is that we have the data A and data B that I have shown you. I'll again write it here. So we have data A and data B. All right. So what I have mentioned that data A is 1, data B is 2, and we
Madam, again, I think you are muted.
Yes, madam, you are in mute.
So please, the it's a request to the participants, don't go for any options and all. We are having one admin person is joining individuals. So please do not mute any other persons in that environment. It's a request to all the participants, please.
so basically here if I go with the relation between data A and data B, so we can here easily see. I hope my slides are visible.
Yes, madam.
Yes, ma'am, it's visible. You can continue, ma'am.
Yeah, yeah. I'm really sorry for the problems and the issues are occurring frequently. So basically, I'm coming up with my topic. So data A and data B are here related by a factor of 2. So that means there is a relationship between data A and data B because we can see that these are related by a factor of 2, right? So if you want to reduce the amount of B, then you have to reduce the amount of A, correct? Right? Because they are related with a factor of 2. So, but what if I tell you that data A is the number of people using a Windows phone and data B is number of people dying in a car accident? Does that mean more people buying Windows phone would cause death of more people? But yes, here we can see that statistics says so. The numbers says so, right? But is it correct? No, they are completely random activities. So how do you know that you're comparing the correct variables or correct activities? So unfortunately, there is no way of knowing. That's the limit of statistics. That is why I was saying that statistics is the art of never having to say you are wrong, because you are the important person who is providing the variables, who is providing the problem associated with the data. So if you are going with the wrong variables, statistics is not going to basically tell you that you are working on the wrong variables. It will provide you some values, right? So in this particular example, we have seen that data A and data B are the two variables, but both the variables cannot be related to each other, right? So basically, you will have to rely on your own intuition, and there is no relation because we have seen that there is no relation between Windows Phone user and number of people dying, right? So the, you have to rely on your own logical abilities while using the statistical method. So statistics always show you some results or you can say outcomes, but it's your responsibility to make it logically correct as well as acceptable. Okay, so let's understand what is statistics. We can call it a collection of number that represents something. For an instance, anything around you, which you can convert into some form of numerical value, is a data. And that's the essence of statistics. For example, you are sitting on a chair and you start observing, like, what is the height of that chair? When did you buy that chair? How much did you pay for it? Etc. etc. So, whatever data is being generated from your observation is the data. right? And now exactly you are on the nerves of the statistics. So I mean to say that statistics is a number who needs to be studied, right? So in the previous example that we have seen, we have data A and data B. So data A and data B are represented with the help of some numbers, and we are trying to identify some relationship between one to within the relationship between data and data B, right? So what we have done exactly, we have the numbers and we were trying to study that particular numbers, right? So for instance, when you have a data based on your observations related, just like the example of the chair, right? Then average price or weight of the chair, or another example could be the average marks scored in a particular subject by the student, or any other example, then each of these data points that resulted into the average is an example of statistics. Not particularly average, but if you are able to derive something from the data, then it is basically a statistics. So more clearly, statistics is all about status of the data, where it is represented as simple numeric value or average value or mean value. All right. So now, if we talk about data science, so initially I just told that data science is the science behind data. So just like psychology, psychology is the science behind human mind, right? Physics, physics is the science about physical phenomena. Similarly, data science is the science about the data. So with the help of data science, you are trying to identify the reasoning about the data patterns, shapes, and relations. So what exactly that means? So if we link data science with science, then definition would be the set of methods for learning about data, and these techniques and theories are drawn from many fields within the context of mathematics, statistics, computer science, information science, and other domain knowledges. Right? So in general, the major objective of data science is to solve business problems, because data is being generated from businesses itself. Now, be it is a business of any manufacturing concern or service sector or any other businesses, but every business need is to effectively use the data so that they will be able to generate decisions with good accuracy and solve the business problems. For instance, I'll take higher education institute as one of the business, right? So, for instance, students' performances are not going well, and and the institute is not able to get good admission. So, how this problem can be solved? So, here comes the role of data science. So, you need to convert the problem into data so that correct cause can be identified. Therefore, in this case, you probably need to collect the marks of the student, marks history, faculty related data, feedbacks, and could be the other variables, and also um, uh, and basically you can also consider these stakeholder feedbacks, right? And then need to identify the relation or non-relation between the variables so that you can come to a right conclusion and make effective decision making. Right. So probably you found that students' performance are consistently going down, right, which leads to effect on the placements and thereby causing effect of admissions due to low number of students placement. Right. So now to basically with this example, to learn data science, you need to focus on data analytics, machine learning, and deep learning. And this is what I have depicted here in this particular slide. There has been always confusion between difference between these three terminologies, right? And now I hope through this you will be able to clearly differentiate between all these terms. So actually, data analytics, machine learning, and deep learning comes under data science, and only machine learning and deep learning combines to give whole understanding of artificial intelligence. Therefore, data science is very important and includes all aspects of methods, techniques, and tools that will help to identify and evaluate a particular type of model or getting insights out of it. Additionally, it helps to scale the business solutions, or you can say accelerate the business solutions. So please mind it that data science is not limited to the scope of machine learning, deep learning, and data analysis, because I'm trying to differentiate between these three terminologies. That is why I have taken these three under the hierarchy. But yes, in data science, we have the flavor of other domain knowledges as well, like big data, and any other domain specific things which can contribute to gain insights from the data. All right. Now, coming next to see basically the journey of data science, you can easily observe from this particular slide that the journey of data science begins from data analytics and gradually moves to machine learning and then deep learning. Now, you can clearly observe from this particular slide that to start your journey in this field, you will be requiring the understanding of statistics, and that's the main crux of data science. If you don't know or partially aware about statistics, then it's true you are going nowhere. So, it is important to understand the need of statistics for learning data science, or at least to start your journey of this particular field. Right. So that is why I took up with this particular topic, statistics for data science, because in real world, many of the IT people or the computer science people don't look at the don't look at the theories, don't look at the methodologies which are involved under statistics. So it is basically important to have knowledge about these statistics, because if you see the mathematical requirements for all these three areas, then statistics is, we have a requirement under data analysis as statistics. In machine learning, we also requiring a statistics, right? In deep learning, we also requiring the statistics, and other things are advanced as we go beyond data analytics. All right. Now, let's concentrate only on the data analytics. As I already told you, that data analytics is all about um, starting with the data sciences, or is all about learning statistics, right? So we can say that data analytics is a summary of data that reveals about what had happened in past. It is all about understanding the pattern of data and inferring out of it, right? So therefore, we can say that data analytics comes with two major phases. One is the descriptive and another is the inferential. Descriptive is all about summarizing features of a collection of data, and inferential is describing and drawing inferences about the data, right? So, what does exactly mean? So, let's suppose I have a data in the Excel format and having 30 rows and 5 columns, right? So, what would be the total number of data points? 150, right? So, I have the total data points 150. Now, if I simply extract the features of the data and show it as a result, then it would be descriptive one. Now, let's suppose I have 1000 rows and 5 columns, then total data points will be 5000, right? I have taken 1000 rows and 5 columns, so it would be 5000 data points. And if I pick a random number of data points from this 5000 data points and make a sheet of 500 values, and then I would try to extract the features of these 500 values or the data points, try to draw some results from them, and then extrapolate these results back to the 5000. Then it would be inferential, right? So descriptive statistics is only about describing the data, and inferential statistics is basically getting the insights from the data. What this data is trying to tell me. Right. Now, you might be thinking that what exactly is the features? I was, while telling you descriptive and the inferential, I was trying to tell you that we are trying to extract the features of the data. So, what exactly these features are? Right. So, as a newbie to the statistics, we can consider features here like what is the minimum value, what is the maximum value, right? What is the average value, which value is most occurring, looking at the spread of the data, right? So basically, these are the features. right? So till now we had a lot of discussion about statistics and data science. We already understood that journey of data science starts with data analytics. So so there is a small activity, and I try to apply data analytics, what we have studied, like descriptive and inferential, on the data and get the concept more understandable. So let's have a small activity. It is only of 5 or 10 seconds, right? So I'll be giving you 5 seconds of time, right? And in the next slide, I'll give you some values. You have to identify features of the data in terms of least value and highest value. What you have to identify? I'll be giving you 5 seconds of time. You have to identify least value and highest value from that data point, right? You need to write your answer in the chat box, and also the answer should be like you have to write least value and highest value together. If you are providing least value separately, highest value separately, then it won't be considered, right? So there would be one single response with respect to least value together, right? So are you ready for it? It's very simple activity. You just have to identify minimum value and the maximum value. So shall we go ahead? Are you ready for it?
Yes, ma'am.
Okay. So your time starts now. So the time is up. Now I wanted to see what are the responses that I have, because it's only for 5 seconds, and I think where is the chat box? Not able to see it. Yes, madam. Madam Sheila has raised the hand. Madam Logeshwari also raised the hand. So what is the minimum and maximum value? I have given 5 seconds of time, but yes. Oh, okay, it's okay. Please tell me, ma'am.
Ma'am, please enable chat box, ma'am.
Yes, madam. Enable chat box so that we can type.
Uh, the chat box would be enabled by me.
Yeah, no, I'm sorry, ma'am. Like, if you don't mind, as the mic option is enabled for everyone,
Okay,
you can please unmute and talk. And then, I mean, the settings are not able to change right now. So please
all right.
unmute and you can tell the answer.
Not an issue. Madam Sheila, what is your answer, please? So it's just a small, simple activity. I was hoping for a good number of responses. But anyways, let's move ahead without wasting the time. So I think I'm considering those who have raised their hands have some answers, and I'm considering those answers to be the correct ones, right? So let's suppose I have a good number of participants for this particular FDP, and few of them have given the correct answers. Possibly, it uh, some of them would give the answers in the form of only the least value. Possibly, some could give the answers in the form of only the highest value, not together, and some answers could be the wrong, right? So therefore, now what we can infer from this particular activity, what I'm trying to tell you from this particular activity, right? So basically, what we are going to see here, that just by looking at the data and the way you experience in identifying the least value and highest value, you have concluded something, you have deduced something, right? And why we have got such answers that were partially correct, right? And why this happened, that few of the respondents have responded to this particular activity. So basically, we can draw some inferences from that, right? So let's suppose I have 60 participants right now, and 10 of the participants have given me the answers. So here the results or the conclusion that I am drawing from these 10 participants is going to be extrapolated to those 60 participants. So what I am thinking that if 10 participants are acting or giving me the answers in the same form, so possibly 60 would also give me the answers in the same way. Right. So this is what the inferential statistics, where you are trying to extrapolate those results to the whole population. Right. And what is the reason that we have got some partially corrected answers? Right. So this could be one of the reasons, and I would like to have response from your side that possibly we have got some good answers. Possibly we took some greater time to analyze the least value and the maximum value. So any one of you can tell me what is the reason behind this, that we took few more seconds in identifying the answers or possibly the wrong answers? Can anyone having the reasoning behind this by looking at the data? All right. So basically, if you see these particular data points, so these data points are not arranged. These data points are not sorted, right? So if these are sorted, you are able to identify the least value and maximum value in 1 second only, right? By looking at the first value and the last value. Right. But since this particular data is not sorted, you took more time to identify the least value and the highest value. The second reason behind this is basically the time. I have given less number of seconds. I have given you few seconds to identify the minimum and the maximum value. So possibly if I had given you the greater time frame, you would be able to identify the correct answers, and possibly all the 10 participants or all the 60 participants would able to identify the minimum and the maximum value. So this is what you are trying to do by looking at the data. You are trying to infer from this particular data. So from this activity, we can easily analyze that what is descriptive and what is inferential statistics. The descriptive statistics is what is the maximum value, what is the minimum value, what are the total number of values over here. This is what descriptive. You are just directly extracting the features from this particular data. And what is inferential statistics? What are the causes uh, of not getting the correct answers? What are the reasons that all the participants have not given the answers? Right? So basically, these are the inferences, or these are basically the results that you have drawn from this particular data point. Right? Now, throughout this discussion, we have tried to identify the characteristics of the data, but why we are doing this? So the major factor is the automation, which is driving data science. So at first step, we have identified the characteristics of the data and applied it to all the data points. Now we will see how to automate it, because we are uh, saying that the major factor is the automation, which is driving the data science. So first we will try to understand the data with the help of statistics. Then we will move ahead to the machine learning part, so that we will be able to automate our problems, or our solutions of the problems with the help of the machine learning, right? So here comes the role of machine learning. We will see a short introduction about the role of statistics in machine learning, and then we will come back to the concepts of data analytics, so that so that today we must have some takeaways from this particular session, right? So basically, so machine learning, you have frequently seen such recommendations, not exactly this one, but this is one of the good examples that I thought to share here. So basically, you have frequently seen such recommendations, not exactly this one, but yes, while using online shopping apps. So obviously, you are not going to buy a single piece of shoe for one foot. And this sense we need to develop for machine as well. right? So this is my human mind, which is basically telling me that I'm not going to purchase a single piece of shoe, right? I need to have a pair of shoes, and since machine has no intelligence, but I need to develop this sense to machine as well. So therefore, we can say that machine learning provides computers with the ability to learn without being explicitly programmed. So we are making machines able to learn through its experiences as human does. So let's try to understand it more deeply. Consider you are trying to throw a pencil into a drawer. So you are standing at some distance from the drawer. While throwing, you realize that sometimes you have put too much of force in it. Sometimes you realize that you are closer to the target, but you need to increase your throw angle. And sometimes you got diverted from your target, right? So basically, what is happening here, after every throw, you are learning something and improving the end result. Therefore, it can be said that we are learning from the experience of each throw, and thereby you are programmed in such a way. Now, we can do something similar with machines also. We can program a machine to learn from every attempt, experiences, data points, and then improve the outcomes. Consider the same example for a machine and non-machine learning program, right? So what I'm trying to say here, machine learning program and the traditional program. So in case of non-machine learning programs, or you can say a general program or the traditional program, would tell computer to measure the distance and angle and apply some predefined formula to calculate the force required to throw the pencil and put it into the drawer. Now, if you add a factor of wind force using fan to your environment or to your setup, or if you change the environment, means right now you were trying to throw the pencil in the closed space, but now you are trying it in an open space. So environment got changed. So this program will continuously miss the target because it is based on some predefined parameters only, right? And it won't learn anything from its failed attempts. So to get the outcome right, you need to reprogram taking wind factor, type of space, etc. into your formula. Now, same case with the help of machine learning program would begin with a generic formula, but after every attempt or experience, it will refactor its formula. It will automatically adds the factor into its formula, and as the formula is continuously improved using more experiences, the outcome too improves. So here data points are the experiences that you are adding for a machine to learn. And basically, we all see these things into action around us in YouTube's video recommendations, Facebook's newsfeed content, etc. Right. So there also machine learning algorithms are continuously improvising themselves by adding the factors or by adding the choices of the user. Right. We need not to go back to the program and add the factor. All right. And there is no human who is watching the choices of each and every individual user who is watching the YouTube video. So how you are going to have your choice of video in the home screen? Right. So this is what the YouTube video recommendation and here machine learning is working on. Right. So we have tried understanding what is the statistics and what is machine learning separately. Now let's see them together. So I found this comic really interesting while exploring the content for this particular PPT. And before proceeding further, first of all, I would like to mention that this image has been taken only for educational purpose, and credibility is also mentioned with this particular picture. So what I was saying that this picture clearly reflects what is the statistics for machine learning. We can say we are not just trying to glorify statistics or collection of numbers using machine learning, right? But also we are providing greater boundaries to the statistics. But yes, we cannot deny the fact that statistics is one of the prerequisites to the machine learning. So why I am saying this? Because you cannot just use the data without understanding it. and it is must to observe the data to explore the descriptors associated with the data, the relation between the variables, and many more things. If you do not perform this, then probably you may lose direction while implementing machine learning algorithms and possibly could do a disaster with your data or with your problems, right? So that is why statistics is the first step towards machine learning, or you can say the data science. All right. Now, from the number of examples, we have tried to understand the significance of the statistics required for machine learning and, of course, data analytics. So, statistics is a core component of data analytics, right? Core component of data science that includes data analytics as well as machine learning, and it basically helps you analyze and visualize data to find unseen patterns. Okay, so now we have arrived to a point where we are sure about the fact that for understanding the data, statistics is the first step. And we all know that descriptive statistics and inferential statistics are the two major areas or two major phases of the statistics. So let's come back to the first step of data science, that is the data analytics. All right. So let's discuss more about the descriptive statistics and inferential statistics and the related terminologies of these two. So, descriptive statistics are basically for describing the properties of sample and population data. So, basically to identify what has happened in the past, and and other one is the inferential statistics, which is basically used, or you can say, basically uses those properties which we have gained from the descriptive statistics to test the hypothesis or the assumptions to reach at the conclusions and make some predictions or make some recommendations that what you can expect from that particular data. So let's deep dive into all these concepts. Since we have talked a lot about descriptive statistics are for describing the properties of sample and population data, therefore let's first discuss about population and sample. And in very short terms, I would try to explain it very quickly. So, in statistics, the population comprises all observation, or you can say data points about the subject under study. And sample is a subset of the population. So it is clearly depicted from this particular slide that sample is a small portion of the total observed population. For an instance, there is a kids apparel manufacturing company, and they would like to know all the kids stores where they can sell their apparel. Right. The company has the population data on the total number of kids stores on a particular place, and let's suppose I'll take it as Delhi only. Now, this kids apparel manufacturer can create a research sample by only selecting the kids stores that sell kids apparel of age group 2 to 5 years only, right? There's a sample will be the kids store of age group 2 to 5 years, and population will be all the kids store in the Delhi. So basically, we can say that population is a superset of sample, or in other way, sample is the subset of the population. So in this example, this is my whole population, and I am randomly picking up few of the persons, right, to get my data collected. Whatever result I get from my sample, I will try to extrapolate this particular sample to the population. And while selecting the sample, we must keep in mind that sample must be a true representation of the population, right? It doesn't mean that if I am going to conduct a research on higher education students, right? So my population would be all the students who are from higher education institutions, right? So in that case, my sample would also be the students of higher education institute. It doesn't mean I will be collecting the data from the school students or the students which are below higher education, or yeah, below higher education, right? So basically, the sample must be a true representation of the population. Otherwise, you are uh, going in the wrong direction. All right. Now, next we have the measures of central tendency. Now, why we came to measures of central tendency? See, let- yeah, hello, hello, am
Yeah,
I
ma'am,
audible?
please. Yeah, ma'am, audible, ma'am. Please continue, ma'am. No issue.
Okay. So, why I came to this particular thing, which is measures of central tendency. See, when we were talking about the, let's see here, let's suppose what I told you that when we start with data science, we first start our journey with the statistics, right? Now, in the statistics, we have two. One is descriptive and another is inferential. All right. Now, under descriptive statistics, I have this measures of central tendency. I mean to say that how would I will be able to got the features of the data from the set of data points. So for this, I would be using some measures, some methodologies, and that is one of these is measures of central tendency, and another is the measures of dispersion. Measures of dispersion, right? In case of inferential statistics, you have the hypothesis testing, right? You have correlation, you have regression, and so on, right? So in this for this particular session, I am only looking at this particular descriptive statistics. In another session, we could possibly have the scope to cover this particular inferential statistics as well, right? So measures of central tendency is the way to get the descriptive statistics or to get to know about the description about the data. All right. So when we talk about measures of central tendency, what we are trying to say that if I have a certain number of data points, so I am trying to find out the central point of my data, right? And for this purposes, I am using three types of methods. One is mean, which is basically your average, median, which is your middle value, and the mode. Mode is basically the most frequently occurring value. Right. So this would help me to know what is the center of my data. So center of data doesn't mean that we have a circle and we have a center of the data. Center means which data is truly representing my all the data points. Right. Just for the sake of understanding, like in a class, you create a class coordinator, a student class coordinator. So student class coordinator is the representative of of that particular class, right? So that could be the center of that particular class. Similarly, with the help of measures of central tendency, if we have certain number of data points, so we are trying to find out the central value which truly represent my data. All right. And with the help of mean, median, and mode, we will be able to identify the central tendency. So measures of central tendency means tendency to have a central data in the data point, right? So mean is the average of all the data points, and it is very much sensitive to the outliers or the exceptional values. Median is the middle value that divides the data into two equal parts. Once it is sorted, once the data is sorted in the sorted order in ascending order, right? And mode is the value that occurs most often, right? Median and mode both have resistance to outliers. So mean is very much sensitive to the outliers, but yes, median and mode are good if we have some outliers in our data and we try to uh, avoid that particular outliers interference, right? So we can use their median and mode. So for an instance, these three measures of central tendency can be used to rank data in the context of consumer preference and rating. Then using median and mode is very useful measure when you want to keep inventory, the most popular T-shirt or shirt um, uh, in terms of size during the festival season, right? So in this way, these are the applications or measures of central tendency, mean, median, and mode. So I have another activity for all of you. So it is a simple activity so that we will be able to know that whether we have understood this particular measure of central tendency. So we have studied mean and median. Both try to measure the uh, central tendency in a data set. So basically the goal of each is to get an idea of typical value in the data set. Now let's try to identify that for the given scenario that I have, which I am sharing here in this slide, which is considered to be the best measure of the central tendency. I request each one of you to please try at least. First of all, we need to identify the mean or the average score for the golf team members, and then we have to interpret that particular mean score. Please speak up or write your responses in the chat box. First, we'll do the part one where we need to calculate the average value. So, what would be the mean score? Please speak up once you solve it. Anyone? Alright, so if I go with the average, how do you calculate the average value? You just sum up all these data points upon the number of observations, right? So 70 plus 72 plus 74 plus 76 plus 80 plus 114, right? Divided by 6, right? So possibly I got the answer as 81. Now see, 81, where would 81 lie? Not here, not here.
Hello, hello.
Yes, madam, please.
Chat window is not unable to write, ma'am, for the
Madam,
team
please.
members.
Okay, please speak up with your results. It is always conveyed by
81
this.
and 75 and another mode screen is not actually displayed. Data.
81 is for mean score,
Yeah, and the 75 for the median.
75 is for the median. May I know your good name, ma'am?
Dr. Sheetal Thande.
Okay. Thank you so much, Dr. Shitsu, for your response. It is correct that for average value, we have 81 and median score is 75. Now, what we have to do, we have to correctly interpret this mean score. I got the mean score, but how I am going to interpret this score 81? Now, see here, we are talking about what the central tendency, right? And we got 81 here, right? Now, if I talk about 75, so 75 would be here. So by looking at this particular marking of these mean score and median score, what do you think? Which is the first of all, tell me, which is basically mentioned in the next slide, what would be the best measure of central tendency? Which is the true representative of the central tendency? Can anyone tell me? Mean, either mean, out of mean and median, which is the true representative of the central tendency by looking at this particular marking, 81 and 75.
Mean is always been representing the centroid.
So, okay. So I got one answer that yes, mean is the true representative of this particular central tendency. So I'll come to this particular point later. So first of all, let's interpret this mean value. What is the correct interpretation of this particular mean score? Right. So, in case of basically average score calculation, we can say that if each golfer had scored the same, they each would have scored mean. If everyone has scored same, almost same, which is equal to 80, 81, right? So they each would have scored the mean. This is what the interpretation of this mean score. Now in next part, we have identified median score, how it is basically interpreted in terms of descriptive statistics under central tendency. So basically, median score is showing me that the that 50% of the golfers, or you can say half of the team scored higher than median and half of the team scored lower than median, right? Now I am coming to the next part of this particular one. So the best measure of central tendency or best measure of center is, I got one answer, which is which from you participants, is basically mean. You said that mean is the best measure of center or the true representative of the central tendency. But do you think in this particular case, mean is the best measure of the central tendency? Because why I am saying that, if I go back to my slide and if you try to see this, here 81 comes here. So you can say only one value, or you can say most of the values are far from 81, right? And 100 basically mean is not showing me the central value. It is not showing me that half of the values or almost half of the values are greater than this or lower than this. But in case of median, I am getting the same result. Why it would have happened with the mean value? Because you can see that here there is a outlier. Outlier means an exceptional value or the odd one out value. So almost all values are within 70 to 80, you can say, right? But this value is out of these values, right? And because of this particular value, the average value has been shifted to the higher side. And it has led that the average value shifted to the higher side. And that is why it is not representing the central value. Right. So here in this particular case, the median will best describe the score of the team because the mean is higher than almost all of the scores in the data set. All right. That is why I told you while describing mean, median, and mode that in case of outliers or the exceptional values, mean is not considered, but median is considered. All right. Now let's move to the measures of dispersion. So the measures of dispersion is the another measure under the data analytics under descriptive statistics. So it comprises of a range, interquartile range, variance, and standard deviation. Right. So when we talk about range, then it is simply a difference between maximum value and minimum value. Funda- Fundamentally, it is used in real life to make mathematical calculations. So range can be used to calculate the amount of time that has passed, like when we are trying to calculate our age, right? So we are basically, the current year is 2023, and let's suppose you were born in 2000 or 2002, and you will try to difference between the current year and the day and the date and the year in which you born. So what you are trying to do, you are trying to apply the range, right? Now, if we talk about quartiles, then they are values that divide your data into quarters. However, quartiles aren't shaped like pizza slices, right? So instead, they divide your data into four segments according to where the numbers fall on the number line. The four quarters that divide a data set into the quartiles are the lowest. I'll show you. The lowest is the 25%. So let's suppose this is my number line, right? So I am dividing these data points into four quarters: first quarter, second quarter, third quarter. So basically, the lowest one is the 25%, right? The next is the 50%. This is my 50%, right? The third quarterly is 75%, and in all, I have the 100%, right? The lowest is 25% of numbers. The next lowest is 25% of numbers till median or the 50% of value. The second highest 25% of numbers, which is above median, that is 75%, and the highest of 25% of numbers. So basically, to understand quartiles, the simplest example is the calculation of percentile. For instance, you got 75 percentile, right? So you got what? You got 75%. This here you got it, right? Then what does it mean? It means that 25% of the people in the class did better than you, and 75% of the people in the class did worse than you. So this is a kind of benchmarking you are creating, right? Similarly, in case of quartiles, we are dividing the data set into 4 quarters. So each quarter is 25% of the total number of data points. So the first quartile or Q1 is the value in the data set such that 25% of the data points are less than this value and 75% of the data set is greater than this value. The second quartile or Q2 is the value in the data set such that 50% of the data points are less than this value and 50% of the data set are greater than this value. Similarly, we can interpret it for the Q3 and Q4, right? So last but not the least, standard deviation, which is very much important, is a measure of amount of variation or dispersion of a set of values. So in mathematical terms, it is the square root of variance. Variance and standard deviation represents the measures of fit, meaning how well the mean represents the data. So, for instance, in a company, there is a constant tussle between the employees that they get paid less than others and claim that it is unfair on the part of employer. The employer will then check for disparities by the calculating the average salary and its standard deviation for employees in that particular department. If the standard deviation is higher than the expected, the matter will be looked into. For example, when going through the accounts, the employer will realize that data is skewed because three of the employees are almost 10 years senior to the others and get paid more. Another example is related to your everyday life. You can set a mean amount, average amount of a money for you to spend and check. If you are spending too much using standard deviation, you will obviously not go around doing you will try to make it a balance with the help of mean and the standard deviation value. But actually, we are not going around doing such kind of calculation, and it's simply an instinctual calculation your mind does for you. So basically, in crux, if we are trying to find the standard deviation, so let's suppose I have the average marks in the class as 35 and I have a standard deviation of 2, right? This is my standard deviation and this is my average value, mean. So standard deviation means plus 2 and minus 2. So range will be my 33 to 37. So the marks of the students will range from 33 to 37. So this what standard deviation tells me, that how far is the value from the mean. All right. Now, we can conclude that statistics is a core component of machine learning and it helps you draw meaningful conclusion by analyzing raw data. We can thought statistics as a pillar of data science. So you cannot develop a deep understanding, decision making, and machine-based application without it. If you have a good understanding about the statistics, then you can use it to get answers to important questions and you are able to get the insights from the data. You would be able to understand your data. You can use descriptive statistical methods to transform raw observations into information that you can understand and share. You can use inferential statistical methods to reason from small samples of data to whole domains, since raw observations alone are data but they are not information or knowledge. So basically, data raises some questions which needs to be answered in the form of statistics, such as what is the most common or expected observation, what are the limits on the observations, what does the data look like, what variables are most relevant, what is the difference between two experiments, are the differences real or the result of noise in the data. The result matters to the project, to the stakeholders, and to effective decision making. So statistical methods are required to find answers to the questions that we have about the data. So we can see that in order to both understand the data, used to train a model based on data, and to interpret the results, statistical methods are required. So this is just the tip of iceberg, as each step in modeling the data will require the use of a statistical method. So as a data science practitioner or data science expert, you must have an understanding of statistics. So that's it from my side. There is a lot more to share about the topic, and I have tried my level best to confine my insights with limited concepts and to the time limit. Thank you for being an awesome audience, and thank you very much. I welcome queries from the audience or from the attendees.
Okay, thank you so much, ma'am. That was really a very wonderful session, so elaborative and so much with examples and exercises and all. So before I give my thank you, I would request participants, if you have any queries here, you may kindly ask ma'am. She'll be ready to help you out. Any participant, any queries from the participant side? Okay. I think with no response, I feel that there's no queries from the participants. Of course, there wouldn't be anything because the session was so much descriptive and it was so operative. So I think there wouldn't definitely be any questions there. So thank you so much, ma'am. I'm so glad that we started the session with your session, first of all, because it was, I mean, I could see the interest from the participants answering and all that. And I'm so sorry from our side, like the chat cannot be enabled at any point because of some institute restrictions. So we'll ensure that the next session goes on smooth. So thank you so much, ma'am. Like your session was really useful. Statistics, it's a fundamental of everything, be it data analysis, interpretation, modeling, whatever it is, data statistics is the core of that. And thank you so much for so cleanly and clearly explaining every concept. We really had a wonderful session with you. Thank you, ma'am.
Thank you so much. Thank you. Thank you. Yes.
Yes, ma'am. Okay, so for the participants, today at 2 o'clock, we have the second session, and please kindly join by 1:45 at least so that there's no internet connectivity or there's some problems going on. And for those who are currently facing any problem with the connectivity, kindly try to check with different browsers like Chrome or Edge. I mean, it's working for most of them. I don't know why it's not working. So kindly join well in advance so that you would be able to start the session well enough. Okay, so thank you all. Kindly join again by 2 o'clock with the same meeting link. We'll see you again by 2 o'clock.